Hello everyone, it's November the 3rd. Alright, let's look at today's problem. String comprehension. No, string compression. Given a string, word, compress it using the following algorithm. Begin with an empty string. While word is not empty, use the following operation. Remove a maximum length prefix of word made of a single character, C, repeating at most 9 times. Append the length of the prefix followed by C to comp. Return the string comp. I do not understand. What? Remove a maximum length prefix of word made of a single character, repeating at most 9 times. What if it's more than 9 times? You don't do it 9 times. Oh, yep, here it is. I see why they do it that way. Then you can, you will only have a single digit followed by, okay, yeah, that makes sense. Apply the operation 5 times, choosing A, B, C, and D as the prefix A, B, C, D, E, prefixed by 1. And the second one is, so you do 9 times first, and then you do 5 times, and then you do 2 times. That does not make any sense. Why is this a medium problem? It doesn't feel medium at all. It feels pretty easy, huh? Yeah, so you basically start from left to right. You will just count. You count until you count 9. And then you put it into the compressed string. And then you reset and you keep counting. And every time, either it reach 9 or you switch to a different letter, then you reset the count. Yep, that seems to be, unless there is some trick that I did not foresee. I think this is very, very straightforward. Alright, let's do this. So I will choose a string builder for this. And then what we do is we have a count. Okay. And then we'll say if count is equal to 0, or word dot char at I is equal to word dot char at I minus 1, right? If that is the case, then we say count plus plus. Otherwise, how do we express this? Otherwise, then we need to reset it. Probably do this. I think we have to do another one. And count is smaller than 9. Okay. If count is equal to 0 or this, right? If these two satisfies, then we say count plus plus. Done. This means we can keep counting, right? Keep counting. Otherwise, else, whatever this else is, it's either, no, it's just word is not equal to, or our count has reached 9, right? In that case, in that case, what we will do is now reset the counter, and then we need to put the current into, we should say res dot append string or value of count. And I think I'll also do plus string dot value of word dot char at I minus 1. Does that make sense? That we have to do the previous one, right? And once we do the previous one, we'll set count equal to 1, because I need to count the current one, right? Count the current one. And now we go back up. So count will only be 0 at the very beginning. So in that case, is it possible that we don't check? Now that is possible if we don't start with, if we start with 1 and we start with 1, then we don't have to do this check. Not necessary, in my opinion. And yep, will be like this. We just skip the first one, which is fine, right? Which is fine, because if the second one is not equal, we'll do the first one for sure. And at the end, we'll return res.toString. Okay, let's just run through the 2 examples we have. Take a look. Now that is not right, because I forgot one thing, which is to handle the end. Because when you get to the end, you have to do, interesting. If, that is actually interesting. How do you handle the end? Well, at the end, you'll check if it's equal, then will be count plus plus, right? And then come out. Now we have a count, and we need to add the last one. If they're not equal, then, so no matter what, you have to add string dot value of count, add string dot value of word dot char at word dot length minus 1, right? You have to include the last one no matter what, which is fine. We'll always do that, and I'll run it. Now we're good. So yeah, unless there is stuff I not just overlooked, this gotta be the solution. Just, count the frequency of each letter in word from left to right and compress them into the result. Seems very simple. Okay. Now show me if there is any trick that I did not. That is a good test case, because we want to know. What else are you thinking about? Well, we can do the same thing, but put another one at the front. Yeah, I think that should be it. Unless we time out. Now that will be very interesting if we time out. Now we did not time out, but I do feel that it's very slow. In fact, I probably shouldn't call it O and, because you have to do concatenation. I wonder, is there any way to make it faster? Well, there is some idea I have that I think will make it faster. Let's go. Try making it faster. One way I can think of is use, we do this would, okay, and then we do char array. Okay, do this, do this, do this. And instead of doing that, we say, ooh, we need another thing called j. Okay, we say rest j, oh shoot, right, shall equal to, how do we turn it into, well, we can do this, 0 plus count, and rest j equal to word.char at I minus 1. A reset count. Mismatch cannot convert int to char. Maybe we can coerce it. I know, is it working? Okay, this is working. All right, and at the end, we'll say rest. We'll just do this one more time. We say char 0 plus count and word dot char at n minus 1. Okay, and then the end will be return. I think it's still string dot value of. Okay, and what's the subarray? I forgot. Subarray. Java char array subarray. Just string. I have searched this before and I forgot. I think it's called new string. My bad. So we will do this new string thing. So new string char, not char, rest. I think it's the start and the length. Okay, let's see if this one will make it faster. Index 5 is out of, oh shoot, that is absolutely correct. I cannot do just n because it can get bigger than n. At least I need to do 2 times. Damn, that can be 2 times as big. That is correct. Okay, so let's see if this one make it. It's either timeout. No, it does not timeout. It is faster, much faster. So we went from a 49 millisecond and 16% performance to a 40 millisecond, a whopping 98% performance. So that's that. Yeah, I don't think there's any interesting thing in this. Let's see, compress string. Well, append the count or append the current char. Oh, you probably can append it directly. You just progress. Yeah, you progress it, and then you do. Okay, so that's a good thing. Let's see if we can do. I think we can. Let me try it. So we'll do this. Ah, you can also do that. Okay, that's not expected. Then I can do res dot append count dot append wood dot char at wood dot length minus 1 dot to string. So it's kind of chaining all of them. Okay, let's see. We do chaining all of them, what's gonna happen? I am curious. Good. I think we'll have a new time for this. I think it'll be faster. Yup, it will be faster. I know exactly why. Because we don't have to turn the things into string anymore. We're using the service. We're using the service that's provided by String Builder that will directly turn, you know, the chars and integer into string. So this is more likely the one. Okay, so we are done with this. Pretty straightforward. Now let's do this. Okay, we have some Ghana today. We can absolutely do this. But let's do this in Python. We haven't written Python. Actually, we just did just a few days ago. I mean, just a few days ago. That'll be fun. Yeah, that'll be fun. Let's do this. GC, yes. Okay, so as the, I think the hint, was the hint telling me that? Yes, pre-compute it. So we just need to pre-compute the height first, and then pre-compute what it's going to be. Well, pre-compute two things. One is the height, and the other is what it's going to be when you remove it. All right, so we need to do a height, which I presume will be easier to do if we just use a map. Yeah, let's just use a map. So we say heights, okay, and heights after removal. So I have two, right? And we'll do two functions, def get heights. Self, we need a node, which is optional, tree node, and we need heights, which is going to be a dictionary of str and int. That is not true because it's going to be int and int. What else do you need? I don't think I need anything else. I'll just return an integer, which is the height, right? And we say if not node will return 0, right? If it's not, it will return 0. That is actually not true. If not node, we should return -1. Yeah, that's because the bottom should be 0, so this would be -1, right? Otherwise, we'll say h will equal to maximum self.get heights left node.left heights self.get heights node.right heights, right? So we get two sides, the left and right, and we need to plus 1 plus. That is my height, right? Regardless, that is my height. Once I get my height, I will fill it node.val equal to height, and I will return my height. Boom, that's the first one. So we say self.get heights. We start with root and heights. Now the second function we need to do is called get heights after removal. Same thing, we have node. Actually, no, it's not the same thing. We need to do a little bit ingenuity in here. Heights after removal. These are just regular stuff, right? So next thing is impacting. Is impact, right? Is impact. And what's the next one that you need to know? Well, the next one you need to know is total height, right? So total height and the height of the other tree, other side. Height of the other side. Total height and total height. Height of other subtree. I mean, it's very cryptic, okay? I agree. This is extremely cryptic. It doesn't really help at all, but it will work. It will work. So anyway, you start from the root, right? You start from the root, and it is going to be impacting, and then you do heights after removal. That's actually not true. So what you do is you set it up first, right? And then you go for the left and right. So you go for the left and you check which one's bigger, right? You check which one. So we can say if node dot left, yeah, if node dot left is not null, is not none, right? And node dot right is not none. So in this situation, then you handle some stuff, right? Then you handle some stuff. Then you say if node dot left dot val is equal to node dot right dot val. It also depends on the impact, right? So okay, let's do this. If not impact, let's call it impact. Don't call it is impact. Just call it impact. If not impact, this one does not impact, then we can just set heights after removal. It basically just means if we remove the current node, it's fine. Right? Nobody cares. Node.val, right, equal to total height. Done, right? And then we'll say, actually, we probably should also say if not node, just return. We don't do anything, right? Otherwise, we'll do self.get heights after removal. Or say node.left heights after removal. Same impact, right? Total height, nothing change. Height of other subtree. Okay, I think I have a lot of issue here. Syntax, invalid syntax. Node is not defined. Wait, what the hell? Expected comma found dot. Oh, I was like, what the hell is wrong? This is what the hell is wrong. All right, so we do this. Get heights after removal is not defined. This is not get heights. This is heights after removal, right? We do this and we do the left, and I think we have to do on the other side as well. Yeah, but we don't have to change anything. So that's if not impact, right? And then we return. So whenever it's not impacting, we just keep not impacting. That's perfectly fine. So if it is impacting, so we are on the subtree that is impacting, then, right, we're on the subtree that is impacting, then we check the two subtrees, right? And if one side okay. So I need a left height and a right height. So left height shall equal to node. Oh shoot, I need the other thing. I need the height as well. Damn, how many are you gonna pass to this? Wow, this is getting ridiculous. I have to have heights. Okay. And then we can say left height shall be heights node dot left dot val if node dot left, right? Else, because we only talking about height, right? Else we say -1, and do we add 1? Just like the total contribution from the left, and then we get a total contribution from the right, right? And then we pick one that has the higher, right? Because the one has lower is just going to be not impacting. So we have the one with higher. And when this side with higher is gone, then we can compute how much is lost. You know, we're basically losing that much height. Because if we have this much height, so we just like keep building up. Like I say, height is 10, and I remove a height that is 6. Okay? Yeah, we just remove the height that is 6. Then the total height on this side becomes 4. Then we compare it to the height of the other subtree, and that's how we decide. Okay, so we do the 1. So 1 plus this, right? 1 plus this, we get the left, and then yeah, it's basically the same thing. So we can copy and paste, and then this is gonna be right, and this is also right. Okay, so we get the left height, we get the right height. We say if, oh my god, this is R. If left and the right is the same, then we'll do this. Right, now we do this, and regardless, impact will be false. Because you have both sides, you have impacting on both sides at the same height, then doesn't matter. Whichever side you delete, it's totally fine. You don't have to change anything. Okay, so now else if, oh, what the hell? Now else if, left is smaller than right, okay, then the right is the main impacting. So left, we can keep doing this because left is not impacting. Now right is going to be interesting. Now why is right interesting? Because on the right hand side, we need to find so you're impacting. Oh wait, I'm looking at myself, right? I'm looking at myself. I'm saying if I delete myself, what is it going to be, right? So it's impacting if I delete myself. Now I have a right subtree which provides this amount of height. I already computed. So if I delete myself, then ooh, okay, hold on. Let's just do this. I think it will be easier to understand. Okay, so if I'm just doing myself, right? I say I have the left height and right height, and right has more. And if I remove myself, and on the right hand side, you're gonna lose this height plus 1, right? And plus 2, right? Plus 2, because you remove me. Like if you say I have something like this. This is 0, this is a 1, this is a 2. If I remove this, now it becomes 0. Right? Now it becomes 0 because you removed, I can get 0 height, but I have 2 connections. So that's adding 2. Right? Adding 2. So the right plus 2, and we're gonna get height of the other subtree, right? So what we need to do is to say heights after removal node dot right dot val, no, node dot val, right, shall equal to the maximum height of other subtree, right? Height of other subtree and total height minus right minus 2. Right, we record this and then we do the right side. This will be true, right, because it is impacting. So we do impact total height. Everything else is the same, right? Everything else is the same. The only difference is we set this up, right? We set this up because I know what I am going to be. And of course we have else, which is essentially the same, except we're going to change some stuff. So right hand side can do this, and this is going to be the left, and this is going to be the left. Honestly, I think it'll be better to do this first, right? I think it'll be better to do this first. And do something like this. Right? And then we can call self.get heights after removal. We do root heights after removal. Impact will be true when we start. Total height is going to be it's root val, and total and height of the other subtree. It is either -1 or I think it doesn't really matter when we start. Root heights after removal, impact total height and height of the subtree. Okay, these they require me to give this is int. Okay. Wait, what's the error? Could be none. Don't worry about it. It's not gonna give me an error. Yeah, I'm just thinking at the beginning, I don't really know what height of the other subtree is. Yeah, if it's like a one pass down, you have to find the height of the other tree. Ah, it's actually not that straightforward. Alright, you go straight down, 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 height of the other tree. You never find the height of the other tree. Yeah, you never know the height of the other tree. How do I compute this? You know, you have a left, you have a right, and then you keep moving down. It should be the first one that have. Okay, I think I have an idea. Oh, it's a very rough idea. So basically, if not impacting, yeah, we don't really care. If it's impacting, actually here, we can say if no dot left, if not no dot left, and not node dot right, and impact is smaller than 0, not impact, and hold on, we get this right, and height of other subtree is smaller than 0, because the first one, that's the only one that we care about, right? That's the other one, the only one we care about. Yeah, but still that is not right, because if I have going all the way down, then I split out, and the total height, and then this height, it's just the amount of contribution to the total height. Hold on, I think I need to rethink about this. I have the total height, right? And we are on a contributing path. And if I remove some, I remove this amount of height, then I am not contributing this much. Then I can compute a new height. Okay, I compute a new height. And if I compute a new height, what I need to know is whether the other side is going to give me a bigger value. But it's not the height per se. Yeah, this is not gonna work. Even if I find the first time they bifurcate, right? Even if I find the first time that they bifurcate, it will not, I cannot get the height of the other subtree, because what I want is the height of the other subtree. Now I have the total one, right? I have the total. So if I have the total and I know the contributing part, right? I know the contributing part. Then I can use the total minus the contributing to get how much is in common between them. Maybe. Total height minus the maximum of these two. We'll get a, because this is just this amount, right? So we'll get this part. And suppose that it's like this. So we can use this to plus the other side. Then we get the regular height. So basically we can do this. We can say height of other subtree shall equal to total height minus maximum left and right plus minimum of left and right. And then we can keep going. Right? Okay, so I have done that. I have the other one, and then we just need to do the query. So return for Q in queries heights Q. Not sure. Just lots of words. Lots of words. I think I want to. We have a key error. That is very interesting. Hold on. Get heights. Alright, so all get heights after remove, I want to change it. Okay. Change it after removal, and then heights after removal. That's fine. Total height is fine. We'll do height of other subtree. Change it to other height. Okay. I think I forgot to do it this way. Yeah, that was my bad. I forgot to do it this way. Okay, let's try it again. Still a lot of words. That was not right. That was absolutely not right. Alright, I'll probably just do the first one. What did I return? I returned 4. Oh, easy to get, which is we just print heights. Take a look. 2 is 0, 3 is 1, 1 is 6. 1 is, no, 6 is 0, 7 is 0, 5 is 1, 4 is 2, and 1 is 3. 1, 2, 3. That is correct, which means if you remove 4, you get 2. Okay, so this is fine. Oh, shoot. Now we'll do here, print heights after removal. Let's see. Where does the thing go wrong? 1 is -1. Usually it's fine. I don't really care about 1. 3 is 3. That's true. 2 is 3. That's true because this path is the false path. 4 is 0. That is not true. Because if you do 4, you need to consider this path, right? So we are in the root. First one I say true, so we don't go this way. Left height is 3, which gives 1. Right height will give you 2. Okay, so left height is 1, right height is 2. And oh, I think I got this one wrong. If there we go. Okay, so that one is actually not bad. Let's try the other one. Alright, the second one is still wrong. Oh, I don't need the first one. I just want a second one. Yeah, we can check. 4 is 0, 6 is 0, 2 is 1, 1 is 0, 8 is 2, 3 is 0, 7 is 0, 9 is 1, and 5 is 1, 2, 3. Yep, that is correct. So height is fine, and this is still not fine. We check. Right, we check. 5. I don't really care about 5. 8, if I remove 8, that's 2. If I remove 2, that's not right. How come become 3? Alright, this is 3. 9, 3, 7 is 5. But 8, remove 8 is 2. Because in this case, 9 is 1, 8 is 2. Right? 9 is 1, 8 is 2. And then the total height is 3. 3 minus the maximum of this is 1. Right? Plus the minimum is 1, so it is 2. So the other height becomes 2. And then in this case, the left is larger than the right. We go this path. And then removal should be, this is 2, right? Other height is 2. And then total height is 3 minus, 3 minus left height is 2. Minus 2? What are you talking about? I think it should be minus 1. Why minus 2? Total height minus this height, minus 1. Well, still not solving it. Let's see what other height is. We suppose other height shall be 2. Yep, other height is 2. Other height is 2. But if other height is 2, why 2 becomes 3? Other height is 2, total height is 3, minus left height. Oh, it is minus 2, because it should be 0. Right? Total height minus left height. Oh no, yeah. I'm at 5 at the moment, okay? I am at 5 at the moment. That's why 5 is set to 2. Yeah, that's fine. But it should be this one gets removed. Huh. That doesn't matter. Doesn't matter. When this 5 doesn't matter. But anyway, I'm getting removed. Yeah, I am getting removed. I'm removing this. That shall minus 2. Yes, it is minus 2. Because I am removing myself, right? But from here, I'm checking. This is the first node, right? I have a left, I have a right, and I am getting the other height. Okay. I'm getting the other height. But that should be used for the next level. It should not be used for the current level. Yeah, I think it should be used for the next level. Maybe what I can say is next other height. And then every time when it passes, it will be the next other height. But when we use it, it will be the current other height. Bless you. Bless you. Oh wow, triple bless you. Does this one work? I change it to a next other height. Nope. But this one is right. Okay. Okay, 5 is fine. We don't worry about that. When you go to 8, right? When you go to 8, because at 5, I set the next other height. Shall be 2. Okay. And then you go to 8. Next other height is 2. Right, other height is 2. And then because this is impacting. Right, this is impacting. If I remove 8, oh, that's actually right if I remove 8. If I remove 8 is 2, yes, because if I remove 8, and on this position, I check my left, I check my right, and then the left is bigger, left is actually 1, right is 0, right, left is 1, so we go here, other height is 2, total height is 3, minus left is 1, minus, so it will be 0, which means when you remove this, the contribution from here is 0, so you take the other height, which is 2. Makes perfect sense, right? And then I do the left, because left is bigger, right? And then we do the right, is false, okay? So now we go to 2. Now this is interesting. We go to 2. We go to this node. It's impacting, right? And it's impacting. We have left is 1, right is 1. Oh, this is the problem. This is the problem. It's their children's false, but for this one, when this one is removed, it's not false. It's not total height. I still need to compute it when it gets removed. So this still needs this one. I still need to compute it, the current, right? It is left and right is the same, but you still remove it and then compare, but for your children, it's gonna be not impacting. There we go. Okay, let's do it one more time. Next, other height. Okay, that was a typo. Okay, looks to be alright. We need to copy and paste it back and then write some comments for this. Now, is this the best implementation? I'm 1000% sure it is not. But I think it will work. I think it will work. You know what? I don't like the way I'm doing it. Let's do this. Okay, let's do this. Remove this. Remove this. I want to make this as non-troublesome as possible. Okay, and then for here, I don't need heights. I don't need this. I also don't need this, but I do have to say self. Okay, this is the same. I do not need any of this. In fact, I don't think I need the total height either. Other height I do need because I don't know what other height is. Ooh, self.total heights. And this is basically, I don't need this. I have impact, no total height. Right, and then this is the same. Next, other height. This is fine. Total height need to be a self dot. Fine. man. Okay, all I need to do is self.total height. Oh, I don't need to pass this. Okay. Okay, let me do this self dot. Yep, I think this pretty much explains everything. I think it'll be easier to parse this if we do true. Okay. Yeah, so this is to find the height of the subtree of the binary tree after the given current node is removed. Other height is the second largest height when the binary tree first bifurcates. In other words, other height will take over if the removal causes the original max height to be smaller. Yeah. Impact indicates whether the current node is on the path that determines the max height. If not, removing the current node will not result in any change to the max height. Okay, these are important. So this solution originates from the hint. We go through the tree once to obtain the heights at all the nodes. We then go through it one more time to find out the max height of the tree after each node is removed. Then we simply then we can easily obtain the answer when query. Okay, let's hope it passes. If it doesn't, then I mean today's work is done. So if it does not pass, then we just does not pass. We'll deal with it some other day. Okay, let's see how fast this can be. And it is wrong. Damn. So what type of tree is this? 5, 2, 6, 1, 4. No. No. no, 3. Remove 4. Answer is 2, but I got, if I remove 4, the first one, oh, shoot. Yeah, it is right. It is right. We need to recompute. Darn. Okay, so as we go through, we have to, okay, I kind of know what we need to do. So as we go through, we need to know what level we are at. So at each one, we can compute the 2 sides. Right, when this one removed, yeah, I see. Okay, we'll leave this for another day. But yeah, this is not the right way to do it. So I'm gonna make small changes to it. I think only small change is needed, and it will be right. Okay, I'll do this other time. All right, I'll see you guys tomorrow. Adios.